A bullet is projected upward with an initial velocity of 250 meters per second. First, we must find the equation of the motion of the bullet. Given in the problem the initial velocity, which is 250 meters per second, and that the bullet is moving upward, we can infer that the only acceleration acting on the object is the constant downward acceleration g due to the gravity, which is approximately negative 9.8 meters per second squared. From physics, the height of the object is given by displacement is equals to f of t, which is equal to 1/2 of gt squared plus the initial velocity t plus the initial displacement. So, in order to get the equation of the bullet, we can now substitute the values into the given equation. We have now the equation for the displacement of the bullet. In order to get the instantaneous velocity of the bullet, we must solve for the first derivative of the function t, which is now negative 9.8 meters per second squared t plus 250 meters per second. For the next question, how long does it take for the bullet to reach its highest point? Knowing that when the bullet reaches its highest point, its velocity becomes 0. So, we will equate 0 into the instantaneous velocity, giving us the value of t when it reaches the highest point, which is now equal to 25.5 seconds. Now, what is the highest point that the bullet can reach? Now that we have the value of t when it reaches the highest point, we can now solve for the total height that the bullet can reach. Now, we will use the value of t to solve for the equation of the displacement, which is now negative 4.9 times 25.5 squared plus 250 times 25.5. The value of s, or the displacement, is now 3,188.78 meters. Therefore, the highest point the bullet can reach at initial velocity of 250 meters per second is 3,188.78 meters.